Welcome to the data preparation phase, phase 3 of the CPMAI methodology. If the business understanding and data understanding phases laid the foundation, this phase is where we start building. Here, we take raw, scattered, and imperfect data and turn it into something structured, clean, and ready to feed into machine learning models. At its core, this phase is about readiness. Are your datasets usable? Are your features meaningful? Are your labels trustworthy? Because if they're not, your model won't stand a chance, no matter how powerful the algorithm. Let's begin with formulating your data preparation requirements. Start by identifying what kind of model you're building. Is it for classification? Regression? Clustering? Each use case has different expectations for input. Define the minimum data size needed to train a model that performs well, and know which features are most relevant. Some will need transformation, others may need to be created from scratch through feature engineering. Also, define your data format early. Will your model expect CSV files? SQL tables? JSON? Preparing data without knowing the destination format is like cooking without knowing the recipe. Now here's where modern AI can help. Generative AI is changing the game in data preparation. Let's say you're working on fraud detection but only have a handful of confirmed fraud cases. That's a common problem. Using generative models, like GANs, you can create synthetic data to enrich underrepresented classes. You can simulate rare events. For text-based models, you might paraphrase or rephrase content to create new examples. For image classification, you can rotate, crop, or color shift existing images to expand your dataset. Not only does this improve your dataset's size, but more importantly, it improves diversity, and that's what helps your model generalize to new, unseen data. Next comes labeling, a make-or-break step in supervised learning. You need to define a labeling scheme that fits your problem. Is it binary, yes or no? Categorical, multiple labels? Or continuous, like a range of prices or probabilities? You also need to be crystal clear about the granularity of labeling. For example, image classification might need object-level labels, while text classification might require sentence-level sentiment tagging. Above all, the quality of labels is non-negotiable. Inconsistent or inaccurate labels will mislead your model, and it will learn the wrong things. Spend the time. Get this part right. Now let's talk about data cleansing and enhancement. Start with missing values. Fill them in using imputation, maybe with the average, median, or even a predictive model. Or, if they don't matter much, remove those rows entirely. Then look for outliers, values that are way off compared to the rest of your data. Are they errors or are they important signals? Either way, they need to be handled intentionally. Normalization and standardization are also key. Normalization brings everything to the same scale, often between 0 and 1. Standardization transforms values to a standard distribution, which is helpful when your model assumes Gaussian inputs. This is where feature engineering shines. You can create entirely new features that reveal patterns the raw data doesn't show. A days since last login column can be far more powerful than just a last login date. And sometimes, transformations like logarithmic scales or interaction terms can surface relationships that a linear model couldn't otherwise detect. But here's the thing, you don't just do this work blindly and move on. You need to conduct go, no-go assessments throughout the process. Ask yourself, is the data in the right format? Are the labels consistent? Have you handled outliers and missing values? If yes, then it's a go. Proceed to modeling. But if your data still has major issues, like inconsistent labeling, corrupted values, or insufficient quantity, call a no-go. Fix it before moving forward. Otherwise, you'll waste time building models on sand. Let's anchor this with two real-world examples. In a fraud detection project, the original data had class imbalance issues and missing values. Using GANs, the team generated synthetic fraud cases to balance the classes. They imputed missing transaction amounts using a model based on customer profiles. And they engineered new features, like frequency of transactions and unusual geographic patterns. With everything prepared, they passed the go, no-go gate and moved into modeling with confidence. In a medical image classification project, they faced thousands of raw image files. These images were resized and enhanced using augmentation techniques, rotation, flipping, scaling. Labels were created by medical professionals to indicate disease presence. And corrupted files were removed. Once the data was normalized and cleaned, the team moved forward, well equipped to build a reliable diagnostic model. So, what do we take away from all of this? First, data quality is everything. If your data isn't ready, your model won't be either. Second, generative AI is a secret weapon. It can help fill in gaps, simulate rare events, and expand your dataset in smart ways. Third, labeling is an art and a science. It needs rules, accuracy, and consistency. Fourth, don't forget to pause and assess. Make go, no-go decisions intentionally, not reactively. And finally, great AI doesn't start with algorithms, it starts with the preparation of data that's worthy of those algorithms. Now that your data is clean, labeled, and structured, it's time to move on to modeling. But remember, your AI's success still rests on the foundation you just built here in Phase 3.